So it's getting recorded, right?
Yeah. Yeah.
Okay. Yeah, first question is like unique email address. So every email will have a local name and a domain name, which would be separated by this @ sign. For example, in this is the local name Alice, and leadcode.com is the domain name. And or besides lowercase letters, these emails may contain symbols like dot and plus, followed by string. And if you add periods like this between some characters in the local name part of an email address, mail sent there will be forwarded to the same address without dots in the local name. For example, alice.z @ this, and without dot in the local name will be forwarded to the same leadcode.com address. Note that the rule does not apply for domain names. And it is possible to use both of these rules at the same time. Given a list of emails, we send one email to each address in the list. So how many different addresses actually receives the email? So in this example, there are only two, this and this are the same, because here in the domain name they are using the dot, but in these two, they in the local name they are using, so that's allowed. That's why two here. And these are the constraint. Length will be less than 100 element, I mean every element length, and entire length again less than 100, and each email contains exactly one @ character, and all the local and domain names are non-empty. Local names do not start with a plus character. Yeah, any queries in the question?
So if we have a plus sign, so we ignore all of that after the plus sign, right?
Yeah.
Okay.
Yeah, anything after the plus sign in the first local name, so that should be ignored.
Okay.
Ignored, yeah. Everything, yeah. If you add a plus in the local name, everything after plus will be ignored.
So this looks like a string parsing problem, right? Just look for the @ and then split into local and domain. And then in the
Domain,
local,
yeah.
you just follow these rules and form a
Just
name.
keep a set so that same thing shouldn't be repeated. Yeah.
And
No, I'm saying we can keep a set which would take care of domain name.
Domain name separately and local name separately. That is what you're saying, a set?
Separate. Set, yeah. No, I mean, let's say lead.com, and again, same lead.com shouldn't come. Leadcode.com shouldn't come for that.
Right.
In the final, yeah.
No, but leadcode.com, if it's a domain name, and then we have two different test1 and test2. So should we not concatenate both of them and then put that in a set? So it will be a unique one.
I don't think so. Will it is?
It might so happen like we have a test1 at leadcode.com and test2. I'm just giving an input, a different example,
Yeah.
not this one. Yeah.
Yeah.
So
And test2 for what?
And test2 also with leadcode.com, and then we combine, concatenate test1 at leadcode.com and then put in a set. So we have a unique name, right? And same
So
thing.
in that case, answer will be 2, right?
Right.
Yeah.
Because we are looking for the set size, right? Correct, Shashank? That is what you are.
Yeah. How many? Yeah.
I think set would be a really good way of doing it.
To do, yeah. Map, yeah. Set will be there.
Yeah, I think map and the value will be the list or vector, whatever you use. So the key for the map will be the domain name.
Name, yeah.
And the value will be the list, which will have the local name.
if we use the list, we have to somehow remove the duplicate in the list.
Yeah, then set you have to do over that list.
Oh yeah. So yeah, set, you can say that the map and the value will be set.
Yeah.
Yeah, that is what I was also thinking. But in case what Shashank came up with, if we just have a set and just put the combined local name and domain name of each and every whatever the evaluated inputs, whatever we get, then we put in a set. So we will have exactly non-duplicates also, right? So the size of set is the return
Yeah.
value.
I mean,
Length of
that's also possible.
Yeah.
It's like same thing, like you split it based on this @ and first part will be your local name. I mean, whenever you see plus, only first part will be taken in that case. That remaining part will be ignored, and every dot is replaced by empty space, and just add it the local name @ plus domain name, and at last just return the length of, and this will take care of uniqueness.
Would split return two separate string?
Yeah,
Yes.
two separate string it will be. One will be your local name, test1, and other will be after
Then
plus whatever.
maybe that would
So first part,
require additional space, right? Instead, like we can use the 2 pointer. I mean, we iterate through that and find where the index of the at. But I think that I think it's okay, because at the end we still need to we still need the domain and the local, right? Yeah.
Yeah.
Yeah. Okay.
But Python has such a cool implementation.
Yeah.
I really started loving Python now.
And yeah, I
that's
mean,
what
we need
I
to
thought
focus
in-
more on concept in Python rather than language. In other, go ahead.
I was thinking like Python is so short that in interview setting, it may help to cover more grounds, like finish a problem quicker.
Quicker, yeah.
They give you more
But in
problems.
real world, it's not Python. What I was saying, like, it's not faster, right? Compared to the low level languages like C++ and Java.
That's
and all.
but like you can demonstrate that the algorithmic ability in the interview setting. That's what I was thinking.
Yeah, makes sense.
That's why this language is mostly used in scientific community. I mean, most of the maths libraries, it's available in all other, but it's more of like an English language. Like whatever we speak, we can.
So I can share my Java solution. It's you will.
Sure.
When I look at the Python, I'm not really know, what they do behind the scene. I don't know. I understand, the flow, but I don't know, like, if it allocate extra memory.
Internal.
Yeah,
the internals, right? Yeah.
No, yeah, that's the.
But seems that they have implemented those things very efficiently in their libraries.
So all these things are implemented in C or C++ or Java, and on the top of it, I think Python acts as a wrapper.
Okay.
And I think same is applicable for Scala as well.
Oh, okay.
Okay.
So yeah, what I do is I took set and then I iterate through the list, and for each email, I created a string buffer, and for each email I iterate through the email address, character by character, and if I find the dot, I continue. If I find plus or @ sign, then I break it out, and then I append that append that each of these character into string buffer, and at the end I concatenate with @ and domain, and finally I give the set size. So it's a same approach that you did, but just more line of code.
Yeah.
In Java, it's
But it's
If
more
you look at this-
understandable also. That is true.
Yeah, exactly.
I have one doubt.
Sure.
So
Yeah.
why in the previous solution, why were you replacing that dot character with space?
Because that's allowed now. Like if you have a dot in your domain name, then you can use that. I mean, you won't have any problem. Wait, let me.
So I'm just processing local name, not domain name for
No,
this.
sorry. I think domain name.
I believe it was not removing the dot. It was actually replacing with the
Empty.
zero length string. It was completely removing dot from the local name.
Local name, sorry, not domain name. Yeah, local dot replace.
Yeah,
Dot we are
domain
replacing
name we
it
should keep as is, right? So
as it is. Yeah.
I think Darshan is doing exactly that same.
Yeah,
Processing it.
if you see the example test.email and test.e.mail,
Mail.
both are same.
Yeah.
Yeah.
That's why we are removing that.
Yeah. Okay.
No.
So there are many rules we need to actually take understand it very carefully before even start implementing it, right?
Yeah,
And
it's very
you
easy
need to do that.
problem. It's very easy, but it took me time. And then I was not clearing, like I declared string buffer outside of for loop, like at line 3, the string buffer. So I had like, it never flushed out. So I had like appended. So then I put it under the for loop and now it is flushing out. The other option is I can still declare it at line number 3. But in that case, I'll have to flush out at after adding to set at line number 16, 17. So then I chose this approach where I declare string buffer inside for loop. So it becomes local variable to each email address.
Yeah. So it's within that scope, and if the scope goes out, it goes to the garbage collector.
Yeah. So the problem looks small and easy, but we don't know
Garbage.
something like this.
So when you have implemented, now we look at it and we see it's very simple, but implementing is going to take more time. Absolutely understand it.
It's easy, but it takes sometimes it takes up time.
Absolutely.
Well, I don't get it. What do you mean it's not flushing out?
Let me demonstrate to you. So if I move this line outside of for loop.
Flushing out in the sense giving to the garbage collector.
What is the std out here, right? Now I declared string buffer outside of for loop. So the scope changed, right? Variable scope. So then it adds test email twice because I'm not flushing out.
Yeah, I think that's because something is not right in the for loop.
Hello, am I audible?
Yes,
Yeah.
you are.
Okay. So I was saying that you have written string buffer SB. Instead of initializing it over here, we can write SB equals to new string buffer on line number 6. So means every time it enters a loop, it is again initialized and reused.
So the first time I wrote the solution, I wrote it on line number 4, and then I realized, so I changed it to line number 6, and then it was working.
I'm just saying that on line number 4, just write string buffer SB, and on line number 6, you initialize it.
Okay, so you're saying like that?
Yeah, outside loop, you just declare it. Yeah, and on line number 7, just string buffer SB means, I mean, just SB.
Yeah.
I think that should
work.
That would be the same, right? Because you only define it outside, but every time iterate through the loop, you're gonna create it again. If that's the case, it's rather declare it, inside the loop is better. Because it when it exit the loop, that variable get destroyed.
But here you are assigning new memory space, right? So
So it mean that new, it comes from the heap, right?
Yeah.
Yeah.
So if it will come from the heap, it will go to the garbage collector. But it is still okay, right? It's going to garbage collector. Anyway, it's going to go to garbage collector.
But in this case, I think it's safer to. It's still working, but it's safer to define it inside line 7, because if outside the for loop, nobody can be able to reference it, right?
And what is the benefit to declare it outside the loop?
Nobody can reference it.
No,
right?
I mean,
because
right now,
after the for loop, people cannot reference it.
Right now, it's actually declared outside the loop. So what is the intent to declare outside the loop instead of declaring at the line number 7?
There was somebody suggested. Who was it?
What is the intent? I'm not able to understand that.
No, actually, when Darshan was doing that, actually he was trying to even allocate memory outside the main for loop. He had to flesh that out explicitly, right? So then he was trying to show different ways of doing it, and I think Shivani suggested that why don't you declare that SP outside, yeah, so that is a different style actually, I would say, and I'm not sure how much it's going to have an impact on performance in the terms of space also, but both are okay. And
yeah, I think
ways of doing it.
Compiling and parser wise, it will do parsing. So compiling and parsing will do once, but then, or if it is in the for loop, I'm not sure if the for loop will create local variable every time, a new variable. And here it is like the pointer is there, it's just allocating new memory space.
Exactly. So it will use the same reference actually.
Yeah, same.
Okay, yeah, that might be a bit advantage.
This is actually a little faster than the other one actually.
Okay.
So if you compile and you see the bytecode, so you will not see any difference at all.
No, they say that there will
your
be some
compiler is smart and it will take care of that, as there is no reference outside, so it will actually keep it local.
No, if that's the case, then.
But it depends on what optimization level you are setting in the compiler. So if you are giving that optimization, then it will do that. If it's not, then it will take care of that also, the reference part.
Maybe we should put on Stack Overflow and see.
Yeah.
So there are already some discussions around this on Stack Overflow. This was one of the code review comments I was dealing with. And the best practice here is that you just worry about the usage of this variable. That is, you limit the scope till where you need this. So because there is no real impact on the performance as such, because the compiler is taking care of it anyways. So if in that case, all you care about is scoping down the variables up to the points till which they are needed or they are supposed to be used. So in this case, it should be moved inside. But this is actually a very code review type discussion. I'm not sure it's something interviewer would ask, but you never know.
They will not ask, but if it's a, as I raised that concern in past as well. So if that interview is for your language, or they have data point to check your language capability, they have data point for your how to write your maintainable code, then that will be actually considered here.
Sure, it may give you some brownie points as well.
Yeah, always declare your variable close to where you are using.
Yep.
Or at least you should be able to give a reason, right, for why you're doing that.
I see the problem here is because we not clear the string buffer, every time we iterate through the loop. If we define it outside, right, and then every time on the outer loop we clear the string buffer, then we can reuse that string buffer instead of keep creating the new one.
Yeah, it will have same impact as a new string buffer, right? Like you can, after adding to the set, you can possibly
Clear it, yeah.
your string buffer here.
Yeah.
But then it will have almost similar effect as creating new one.
No, because
why
you
is it
use
immutable? Is it mutable?
Strings, no, immutable in Java, I think strings.
String buffer is immutable, then yeah.
no, it's
String
mutable.
buffer is mutable.
String buffer
Then yeah.
But
Then it will surely have an advantage, right? You just clearing here because you're just using the same space, reuse of the space.
But if you're talking about optimization, we should have used string builder. Buffer is like thread safe. It's like little slower than builder.
Yeah, the difference between string buffer and string builder is string buffer is good for multi-threading.
Yeah.
String builder, it doesn't care about thread, so it does not use the internal lock. That, you know, that's.
Can we please switch to the next problem?
Yep.
Yeah.
Yeah, thank you.
Okay. But that was a good
String is
discussion.
immutable, right?
Yeah, yes,
Yeah,
string is
string is
immutable.
immutable.
Okay, yeah. Yeah, so like ugly number 2, we need to find the nth ugly number, and ugly numbers are positive numbers whose prime factors are 2, 3, and 5. So n equal to 10. So these are the first 10th ugly number you have to find, and that is 12 in this case. That is typical. One is an exception, like typically treated as an ugly number and shouldn't exceed 60/90. And should not exceed that. Yeah. Queries or approach in this?
So when n equals 10,
yeah,
and how do we count, like divide by 2, 3, and 5, right? Okay. Okay, yeah.
So how I did was like starting from 1 and multiplying by 2, 3, 5, what are the results, put in a kind of a priority queue.
Yeah.
And then again take the smallest out and multiply by 2, 3, 5 and put in the queue. And also take a kind of visited thing. If I put that already in the queue, then avoid it.
Yeah.
What is the limit of n? N is there a limit?
1690.
So only remove till you reach 10
Okay.
iterations.
I want to share the code.
Yeah, I can share that.
Sure.
So 1 as an ugly number is a special case here, right?
Yeah, because every number will have 1 as a prime factor, right? That's why 1 is treated as an ugly number.
No, but the ugly number is supposed to have 2, 3, or 5 as their factors. 1 doesn't have those as factors. So I think they are just starting with 1 just in case.
Yeah, it's just to start with 1.
Yep.
And have visited, which would be set. And then for every number we are pulling from the queue, putting 2, 3, multiply by 2, 3, 5, and again put that in the queue. And make it visited.
Adding to set.
Oh, so it can repeat. It visited. Okay. So maybe later there could be repeat. No.
Yeah, there could be repetitions.
Okay.
How repetitions will...
Like 2 in...
Sorry?
I think ugly number will be always a unique one, not a repetition at all.
No, it can come, right? So when you have 2, you multiply by 3, 6 will come. When you have 3, you multiply by 2, 6 will again come.
Yeah.
Okay.
So basically we are starting with this thing 1, and then removing 1 we put 2, 3, 5. Then 2 is the smallest. We'll take 2 out and put 4.
You're
6,
writing
and-
out.
Sorry?
Screen, I mean, if you're writing, it's lagging, that's why.
No, I can see it. It's on line
Okay, okay.
20.
Okay, yeah, now
Okay.
it's
So because this is a queue, it will, so right now it is still holding the property of a queue, product queue or a heap. And then 3 is gone. It will try to put 6, which is already there. And then 9 will come, and then 15. Then 4 should come at the top because it's a queue. So 4 is gone, and then we'll put 8, 12, and 16. So this time from the queue, 5 should come out, and it will try to put 10, it is already there. And 15 is already there. Then we'll put 25.
So are you
Next.
saying the priority queue won't put any duplicates?
Yeah,
You have a visit there.
because we already have visited that.
Okay, you're looking for the visited one. Sorry.
10 is already there.
Yeah.
So I don't want to put it again.
You're not putting it here explicitly.
Yeah, then remove 6 and then put 12 is already there. 18 can come and 30 can come. Then 9 will come out. Was it-
8, I think.
Oh, sorry, yeah, 8, you're right. So 8 will come at the front. So 8 will go out in the same way, then 9 will go out, then 10 will go out, and at the 10th iteration, we should have 12, and then it will go out. So that way we'll able to get that.
So how fast the queue grow? See, every time we process a number, then we multiply it by 2, 3, and 5, right?
Mm-hmm.
I try to see the space complexity.
Space, I can't say how much it would be, but putting in a queue would be like a log n. So any
Whatever the length of the queue at that point, like at
Yeah.
time equal to 2 or 3, that would be the maximum.
Yeah. So as soon as it grow, the log
Go off and on.
will grow. So basically, this is current size of queue.
Yeah, so what would be the time complexity in total? I'm a bit
And in
confused.
log n,
So time
every element we are
complexity would be like we are running this loop 10 times, and under that we are doing 3 times multi, which will be constant. So it will end into, I will say 3.
no, you are heapifying also, no, after each step.
Yeah, we are doing heapifying, ending to 3.
So log n.
Into 3 into then this log of size of the queue. But we are removing things also from the queue every step. If you see. So things are coming out also and going in also.
Yeah, so that also takes. Yeah,
So it will grow by 3.
that is twice of log.
No, but if you see, we are also having a visited
Yeah,
thing.
it will be constant.
So this will become kind of a constant at some, I like that's what because we are removing also, checking visited also. So technically we are putting 3 elements, but it might be only 1 element we are putting. At some point we are not putting any element if it is already there in the queue.
Yeah.
So let's take the worst case.
But we'll have to take for the worst case, like you maximum what is the length of queue you are using?
So let's say
initially you had 1, next time you'll have 3.
number we are putting 3 times. So that would be.
No, it's not necessary, I think.
I think it would be
It
n
can
log
be
n.
more than. Okay. Yeah, n log n. Hmm. See, first time you are putting one element, second
I'm
time
not sure
3
how to
elements.
take care of this
Next, third
visited
time, what will happen? It will grow then.
But it's not going to grow
Third time,
too
how
much,
many
right?
will have? 1, 2, 3, 4, 5, 5 elements.
So first time we put
It will
1.
grow.
So first time we put
One
2,
element. Yeah.
3, and 5. So then 2 is gone. It will put.
Okay, you're starting from there. Okay.
Yeah. 6.
4,
no,
6, and
sorry.
10 to that it will add.
4, 6, and 10. Yeah. So basically, it is going by 3 times. Every step.
In the worst
yeah,
case.
but size won't be a multiple of 3.
Plus
yeah,
3.
It can go because now you will remove 3. Plus
Yeah,
3. You can.
That's what we are discussing. Worst
Yeah,
case,
plus 3.
like I mentioned earlier, also we are removing and adding things.
Where are you removing? I only see heap push, right?
No.
Oh, pop at line 12.
Line number 12.
Yeah.
Pop that line. Yeah. Line 12. Yeah.
So it is n log n then.
No, adding thing and insertion operation is always log n in the heap. It's not n log n.
No, but you're running the for loop at 11, line 11. So every heap.
So considering yes.
Yeah.
So let's say our size is worst case. Our size is m.
Total.
At some point, average size is m. So it would be n into 3 into log m. So let's say some place like the size became m. So that would be the thing. I will separate out the size and other things like considering some size m.
Yeah. That makes sense. Yeah.
It's not necessary at every iteration you'll have a minimum number that you may have to append next iteration and then you might get that number.
Mm-hmm.
Yeah, so the maximum like it, I mean, m can be equal to n also, like entire tree you have to heapify that entire queue, whatever. Yeah.
Mm-hmm.
I think the maximum size of the heap would be n minus the common multiples of 2, 3, and 5, because these numbers are the ones we are not adding in the heap.
But every time it's not that you'll have common multiple, only one number or two number you can have, like 6 already, then 2 into 3 I've done 3 into 2, 6. But at that time 10 is not already in your set, so you're adding it.
We are again removing things.
Yeah. Yeah.
So yeah, it would be, so that's what, like, I would say like m, some size m. If interviewer wants to go more deep into that, then it's a different case, but I would come up with some average size m.
Yeah.
Yeah.
Okay, I think that was, I think there's other ways also to do this thing.
Yes. Yeah, you just whatever you did, simply you can go, what you say. There were repeating some problems, right?
Yeah,
am I
there's some
audible?
repeating.
Yeah, so you can use help, or you can take use of DP, and that may reduce it to order of n. I'll share, let me. So what I was saying, like, let's say if you have this is your array. First time you'll have 1 as this, right? 1 is an ugly number. So I'll take all the 3 pointers, like product when multiply with 3, when you multiply with 2, when you multiply with 5. Initially, everything will point to this. Now you multiply 1 with 3, you'll have 3, and 2 with 1, you'll have 2, and 5 with 1, if you do, it will be 5. So minimum of these two you take. You'll put 2. Because of this, when you multiplied 1 with 2, you had minimum this. So you just increase this pointer over here and you remove it out. Next time again, you already multiplied with 1 with 3, 1 with 5, and 2 with this you'll do. This will be equal to 4. Now again, minimum of this you take, that will be your 4, and that you obtained because, oh sorry, you'll have 3 minimum, right?
Yeah.
So 3. Yeah, then P3 will increase and you remove this. And after that, already I multiplied 1 with 5, 2 with 4, and now 2 with 3 you will do. So 2 with 3 will be your 6. And if it is 6, minimum of these two, if you take, that will be 4. So 4 you do, and you increment your P2 with this. So now what you'll have, now here that repetition you can avoid. 2 into 3 already 6, and 3 into 2 also you have 6. So you don't need to add anything. So minimum of these two you take. So you'll have 5 this, and you increase the pointer. Both you have to increase P3 and P2. That is taking care of repetition case. And next time again, you'll have 3 into 3. 3 into 3 will be 9, and 2 into 4 will be 8. So minimum of these two, if you take, this will be your 6, I think. You will have 6, and P3 will be incremented here. And yeah. And again, you'll have 3 into 3 you have already done. So your will be 2 into 4 is done, and P5. I think we didn't increment P5. Here your P5 will be there because 1 into 5, that was somewhere we did at 5. So you'll increment P5. So you'll have 2 into 5 as 10. So minimum of these two will be 8. So you insert 8 over here. And this 8 came because P2 here, because of P2. So you increment P2 and so on. You will get.
So it is like O of n implementation, or it is a constant?
O of n. O of n.
So this is similar to like merging 3 sorted arrays, right?
Yeah, somewhat.
Yeah, you can say, you first you keep similar. In that also we use heap only for merging 3 sorted arrays.
Yeah, that was.
You take the first 3, and whichever is missing, yeah, you increase the pointer for that. Yeah.
Yeah, I think that is also so other ideas also derived in the same way. You have 3 different variations.
Yeah, correct.
But because this one there's at most only 3, so that's why we don't need to use heap in here.
No, heap I used because he was checking already that repetition was coming. That is avoided here. I'm not computing again. 2 cross 3, 3 cross 2.
Oh, so
that
you also use heap?
No, he's not using heap. Shashank is not using heap.
Yeah, that's what I'm asking.
No, I'll not use it. I'll just use the normal.
Yeah, because there's only 3, right? At most there's 3 value. So you don't need to use heap in there.
Yeah, but then you need to take care of all these pointer manipulations, right? And you should be very careful in that. But heap is very easy to implement and understand.
Yeah.
And as you said, like if there are more than 3,
I mean, just take care whichever element you're multiplying.
But with heap, we need to store extra data, right? And this one is not.
Extra
data.
because anytime on the heap we have the size of the heap could be greater than 3 if we implement heap.
Yeah, but maximum, I think it will be more only +9, right? It's not going to be too much. It's going to be just +9 every time. That is also maybe +8 only. Even if you keep on increasing, even if it's like more than 1,000,
every time
it's just going to be 9. So the space is not going to be so much. Yep.
And they've restricted also till N1690, I think.
Yeah.
So that will.
Yeah, could you run through your code?
Yeah, any queries in this? Sure.
Yeah, this looks okay.
Yeah, this is. Yeah. So just I'm initially that creating length of the entire array. I mean, 0, 0, filling with that. Initializing every product T1, T1 to T3 to 0, and first element I'm picking as 1. I'll go through 1 to n, just compute all the products, take the minimum, and whenever you take the minimum of that, let's say 2 you got as minimum. If you got 2 as minimum, you put that inside your array and increase P2 to the next cell and multiply it by the 2. Because next cell you'll have new element and that you haven't multiplied till now. So that is 2 cross 2 you will do 4, or other condition like if we are increasing 3 multiplied by 3. Whenever you face new element, that particular element multiply with this. And if 5 you have this, at last just return the last one.
Yeah, I can give. And where are we checking the repetition part?
Repetition. I'm not this whenever you see that. That's why I'm not using elif here. I mean, if else I'm not using. Once you check that 3 into 2 equal to 6, this condition is satisfied. It will increase your first pointer, and 2 cross 3 is also 6. Then this will also increase at the same time. Both will increase like at the same in the same iteration. If I use else here, then also it will increase. But
look at K, the array K.
I don't think so any repetition can happen.
No, when you these two
at
will
any point
increase
only
at
one minimum will be there, and
yeah, minimum will be only 1, but I'm saying let's 10 has to be there, then 2 cross 5 and 5 cross 2 both will be 10, right? So when you face this one, you'll increase this pointer on low because this will make you 10 and this will also make you 10. So both will be increased in the one iteration.
Okay.
no.
Yeah.
Okay. Nice.
So look at the array K. Is that when you add an index in the array K, so you look back at most only 3 elements. Is that right?
Yeah, only 3 elements.
Yeah. So K size does not need to be n, right? It can be 3.
Not necessarily, right? Because you don't know how you are looking at 3 elements back, but they can be like much more farther than 3 when it grows.
But we only look at K, yeah, T1, T2, and T3. Okay, yeah. Yeah.
But
yeah, that's right.
Because only 3 we are looking, right? This, yeah.
So they call this as a DP solution, right? DP
yeah.
implementation.
Yeah, because of that repetition only. Yeah, it came.
Okay.
Some problems is there. Otherwise, I don't think so. Any things.
Yeah.
And options also you have like you are choosing any of the 3 options, whichever is the minimum. You go with this path, go with this path, go with this, and take the one which is minimum. So those 2 gives you the hint that it's a DP.
Oh, okay.
looks very compact.
Yeah.
There's Python then.
I want to learn Python now.
Yeah, even Asim's implementation was very compact.
Yeah.
In spite of having the heap implementation.
Although it was heap.
Yeah.
Yeah.
But this one, I think for this one does not use anything specialized in Python, right? Because this one, we would implement the same thing in C++ and Java.
Right. So, yeah. But these guys have the style of, writing in a very compact way. So therefore they keep writing it that way.
Less writing, less chance for error.
Yeah. That's good.
An extra space like that array you're taking, that will be, and time will be often.
Yeah.
Yeah, any further, we can switch to next.
Yeah, let's move.
Yeah, we can then switch to next.
Do you guys time yourself when you do this problem?
Bulbs. I like 20 minutes. I mean, 1 hour, 3 problems, 20, 20, 20. It may go to 1.5 hours. If I can complete within 15 minutes, that's good. Otherwise, I'll check for the solution and all. Or maybe there are many other approaches somebody can share.
No, I'm not getting. So Darshan, are you saying timing in the sense of presenting in this forum, or?
When you do problem, like today's problem, you'll code it, right? Like solve it. So during the solving time.
Yeah, it depends. Initially, it will take more time.
Yeah, gradually.
But sometimes you have to look for the discussions.
Yeah, definitely.
Because that is the reason. That is the way you'll get more inputs, and then maybe your thought process will expand, something like that.
But do you time yourself while working on it, or you just go about it?
Yeah, usually time for at least maybe max 20 minutes, I would say now.
Yeah.
If you are not getting, then it's no use of actually spending more time, I would say.
Somebody's phone will come, then that will expand to largest.
Yeah, true.
Yeah, that. I think 20 minutes or half an hour is sufficient.
A reasonable time, yeah.
Otherwise, if you spend even entire day, you won't get it. We have to look for the discussion section or solution.
Sometimes you look at the solution. Even you look at the solution, you don't understand it.
Yes.
I mean, it said that we need to look at others' code to improvise our code. Like, I mean, expert coders, they have more compact way of writing the codes rather than if a native user writes the code.
I think that was the yesterday's example, which the implementation was very different. Yesterday, yeah.
That articulation one.
Not articulation. There's something before that.
The longest subsequence.
Yeah. Increasing subsequence.
And log n.
Yeah, and log n. Yeah, actually, we saw a lot of people posting on the Slack channel. That was really good.
Yeah.
That was easier actually. In fact, when went through
after going through.
Yeah. Yeah. Let's move on to bulb switcher.
Bulb switcher. So it's like n bulbs are initially off, and we need to first turn on all the bulbs. Then you turn off every second bulb. On the third round, you need to toggle every third bulb, and for the ith round, you toggle every ith bulb. Nth round, you'll have to only do it for the last one. So you need to find how many bulbs will be on after n rounds. So if there are 3 initially off, then made it to on. Now every second, so this will be off. After that, last one you have to make it as off. And last one, for nth round you only toggle in the sense if it is on, make it off. If it is off, make it on. So at last we'll have only one bulb which is in on state, I think. Yeah. So 1. Yeah. Yeah, any queries or how to approach in this?
So
yeah.
for the first one, we turn it on, and then
Off.
that's it. We not gonna never touch it again, right? Because the first iteration is one, we turn it on, and then the subsequent iteration we never touch that light bulb again.
Yeah, definitely. Because after that, every second bulb you have to touch. Mm.
So the number of the number of time the light bulb is on and off, right? If that is even, then it always off. So let's say if we have a prime number, right? Then is that prime number? Let's say the light bulb at a prime number, then that always off, right? Because the first one is on, and when it comes to that prime number, turn off.
So are you saying if there is always a prime number, the bulb is going to remain off?
Yeah.
So, but that will be the case of many others also, right? Not even prime. So more like if it is 6, right? So yes, that also will be off.
Yeah. One.
I think it depends on the number of factors I have till that particular bulb upon I. If it is even, then I think that would be off. Otherwise, it would be on.
So you're saying you take the factors and then
basically the number of divisors, yeah.
And then you separate them in the prime numbers, and then you say, is that what
No,
you're
not
thinking?
prime. I am not going the prime
but
way.
but prime number will be off. So like if in 5th round, so 5th will go off.
For example, I have
number.
Two will be also off. In 5th round, 2 will be off, right?
Yeah. The prime number is only like, one and itself, right? So that's always even.
So what I am
that's
saying
why
is,
it's off.
For example, we have the 15th bulb, like the 15th index bulb. So that 16th bulb. So what I'm saying is, and let's say that I is 5. So 2 and 4 would change its state. 2 would make it off and 4 would make it on. So in this way, I was able to have even number of factors from 0 to I for a particular bulb. So in that case, it would be off.
Okay.
Yeah, that looks like promising.
But frankly, coming to a solution on this was very difficult.
Yeah.
Like, even understanding after implementing it, I had to go through the discussion forum.
Yeah.
Yeah.
Because no data structure, nothing. It's totally on like observing the pattern in the this one.
No, it's like, I mean, you think like when you start that, so
Puzzle.
the first one will always be on, right? And in the second will always be off.
Yeah, if you are more than 2, right? Okay.
Yeah, and third will also be off, right?
Yeah,
and now,
last one because
so now it will start from the 4th. So in first round, second round, the 4th will be off, but in 4th round it will turn on. So because the factor is even.
4th round, factor is even,
yeah.
And all the prime will be off.
Because they have even factors, even number of.
They are odd, always odd, so they will be off.
Yeah. So what it was in one of the discussions, they said, you know, like whatever the number you are given, so prior to that number or including that number, you find out whichever are perfect squares. And whatever a perfect square will be your actually the number of bulbs which are on.
Because they'll have prime factors only. Their factors will be prime only.
Yeah, whatever it is. So only those numbers, because 1, 2, 4, 9, 16, 25. So even if you have 26, so you can say just count all those perfect squares and that will be your output.
And how they actually figure it out?
Yeah, if you actually do it, you know, like write it for each and every 1, 2, 3, 4, you start doing it till 25, then it would really make sense. Because at every perfect square, the way Leon was saying, if it is not even, it will be always odd. So then only that bulb will be on.
And for the square, you know, if it be even, right? But when it come to the number that's square, when it comes to that square root number, then that's gonna be odd. For example, 25. So when it comes to 5, is because 5, you know, we encounter 5 only one time, that makes it become odd. The other one would be the pair of, like, you know, in this case would be, you know, 125, right? 1 times 25, 1 will turn on, 25 will turn it off. But when it comes to 5 times 5, that's only happened once. So that make it turn it on.
Now consider the case for 16. It would be turned on and off so many times. So for 2, it will be toggled. For 4, for 8, and then 16 itself. So maybe the perfect square is the answer, but I'm still not able to find the intuition there.
No, yeah, because when you come to 16, right, then you have to see at one point you have to see 4, right? Because 4 times 4 is 16, and we see 4 only one time.
Yeah, that is correct. I'm able to understand that for the case of the squares of prime numbers. But 16, 4 would have just seen 16. There is 4 into 4, that is 16. But then again, there is another factor of 16, that is 8. So when I'm toggling every 8th bulb, 16th bulb will be toggled in that case as well.
Yes, but when you 8, that means when you at 2, you already you know, turn it on. Then when you're 8, you turn it off. That's you know, that what happened when there's a pair. You know, 1, you know, when 2 is on and 8 is off, right? For example, for 1 and 16, when that 1 is on and when it comes to 16, it's off because it's even. But when it comes to 4, it's off, so that, you know, that make it turn it on.
Okay.
This means if it has got, then it will always be straight. Otherwise, it will not be straight, right?
The voice is breaking it.
I am saying that if some number is a prime number, then it will always be off. Otherwise, it will be always off. Just like take the example of 4. So at 1, it will become on. At 2, it will become off. At 4, it will become
on.
So, the example of 8. So 1 is it is on. So I think every event on.
voice is quite disturbing.
Uh,
Yeah,
no,
it's, yeah.
yeah, I'm
No,
saying
it's
that.
not.
I think some problem in the mic.
Yeah, exactly.
Just a minute. Yeah, am I audible now?
Yeah.
Okay. So I am saying that just like take the example of 4. So 1 will make it as on, 2 will make it as off, 4 will make it as on. So I was saying that if even power of prime number always results in on state, and odd power of any prime results in off state. I was saying this.
Okay. Even power of? Can you
Just
repeat?
like prime number is 2, and 2 raised to power 2 will always result in even, means on state.
Okay.
And 8 is 2 raised to the power 3, means prime number
Odd.
raised to the power odd number will always result in off state.
Oh, okay.
Okay. Yeah.
So
No,
you're
it's-
saying whatever raised to that power, if it is an odd, then it
Then
is
it
going
will.
to be off. That might make sense, but
2 raised to the power even
Yeah.
if it is, then it will be on.
Yeah.
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 So then it is a perfect square, right? So
Yeah, exactly.
yeah, okay. Then it is okay. Yeah.
And 2 raised to the power the odd is off. Yeah. No, makes sense.
I think this one of the brain teaser.
Yes. So
type
it is a
of
math
question.
problem or a brain teaser problem. So it doesn't have maybe not a logic, but it doesn't have a very normal implementation and standard
Yeah,
data structure.
when I saw this problem, actually this problem is mainly asked in puzzle rounds. That
Yeah,
let's say many bulbs are there, and so what will happen at this state. So when I was solving this today problem, so what I did was I was doing some logic will happen. So I started with ranges. Like I started with when 1 bulb is there, then 2 bulb is there, then 3 bulb. I go on until 8 bulbs, then 9 bulbs. Then I saw the difference. What is the difference? I saw the pattern. So I saw that it is just like square root of that number and calculate the floor of it.
Yeah, exactly.
Yeah.
You have to do the whole thing, keep on writing it for some time for many pairs, and then it will come to the solution.
Conclusion. Yeah.
Yeah, that is what I was trying. It was very cumbersome to do that though. Yeah.
Yeah.
But that was the only way, I would say. Yeah. Or else write a program and do exactly the way it is till you have a TLE, and then look at the results.
No.
Okay.
Yeah.
So what is your implementation?
Yeah, it's same. What I'm just taking the floor, like converting it to into the nearest square root, whatever you're taking. Let's say if you have 6 square root will be like what? 6 will be 2 raised to the power 3 is 8, right?
It would be just like square root of 6 will be around 2 point something, and calculated floor, then it will come out around 2. It would be 2.
Yeah, that in time taking.
Yeah.
Yeah. And for exactly perfect square, you'll have what she told, like at every it is a power of what? 2 raised to power 3. So, and every perfect square will always have your even factors, I think. Every perfect square, let's say 9 is the 9's factors are 1, 3, and 9. No, it will be odd. Every perfect square
Yep, actually you need the odd number of factors, and that is why the perfect square is working out. Consider the case of 6 and 4, right? 6 has even number of factors, 4 has odd number of factors, hence the fourth bulb would be on.
No.
So basically this boils down to finding out the numbers which have odd number of factors. And if you look at every square, perfect square, it would have at least the total factors of its square roots into 2. So that becomes even, and then 1.
Oh, the 1 you have to add, yeah.
4's factor is 1, and 4 square root is 2, right? Plus 1, yeah. 1 plus 1, 2 even, yeah.
So why, can you explain why it is the n to the power of 0.5?
I think that is square root.
Square root.
But the square root, they're going to read. So let's say 25, square root of 25 is
Let's
5.
take 9.
Right?
I think because 9 I have written, it will be better to visualize. 9 square root is 3, right?
Okay.
Hmm.
So 3.
Yeah.
So how we know 3? So what at what label the lies on?
1, 2, 3, 1, 4.
Oh,
and
okay. You look
9.
at that.
Yeah.
Oh, I see. Oh, so you look at the bit. What?
Yeah.
Whatever, count the number bit on.
Yeah.
Okay.
Mm-hmm.
Nice.
Because we have to return the number of bulbs lit, right? So
On, yeah.
Yeah. So here the odd factor doesn't come into picture, but the odd factor comes into picture only when we have to see if a particular bulb is on or not. Yeah.
So
So
its nearest.
is that like we look at 9, we have 3 on, right? So we just, if we want to know what, so when we know what the label on, we just do the bit mask.
Bit
like,
masking.
right? Is that?
Actually, yeah, but instead of doing that, we just count.
Yeah. We can count, but in case if they want to know what labels on,
Yeah,
if they ask what labels are.
Yep.
So initially your mask will be 1, 1, 1, right? Or all the 9 places will be filled with 1. And then mask it with the whichever number you like. With 3 you want, the all others will be 0, only 1 will come out to be which bulb is on.
Yeah, you'll have to go through a for loop, and every time you'll have to change the length. You start with, first you do with 1, then with 2, then with 3. So at each and every gap you find that bit, whatever is set or whatever the number is instead of bit, and change the state. That's all. So if you keep doing it, then you'll get this. But if the n is too big, then it will not work. Actually, it will give a TLE.
Yeah.
So that most can be fit into an integer or long 64-bit.
No, I actually took an array. It was a very inefficient way of doing it. So, but because I think they have not mentioned about the size, but if we take integer, it is huge, right?
Size they haven't mentioned.
They have not mentioned it, yeah.
It's written brain teaser maths, yeah.
And if it is just 32, I don't think so. Then 32 would be a small number if you just look at the number of even 64 long integer or 32-bit integer. So that doesn't make sense to have only for n bulbs.
I think the array can still be figured out because it is saying nth round. So we can take the size of just an array, n size array, and for each iteration we will just toggle till n.
Oh, you're saying just take an array of size n, right?
Yeah, yeah.
Okay.
And iterate over for n times.
Hmm.
We can just toggle the values. We just
Right.
then editing for edit now. So we will either just 10 at size and it was so its time complexity is still I think order of n only, and space is order of n in worst case.
Yeah. But I'm not sure what the test cases are inside this. But yeah, let me try that again then.
Yeah, sure.
Yeah. But the way Leon was saying, if we just take bits, then a single integer won't be enough, right? Because the n might be too big also. So that was his concern there.
But I'm still a little confused about the bit. How does it? Okay, let's say on line 15, what line bulbs on? Are we go from left to right or right to left?
I think left to right, right?
Using bit masking, you have to find in that case.
So from left to right, the first one is the bulb like 1.
Yeah.
2, 3, 4. Yeah. Yeah. Okay. Yeah. Okay. One base 1. Okay. Not base 0.
Yeah, not base 0, but when you have to implement in a bit form, you'll have to use that 0 also. So it will be more trickier implementing in a bit form.
And that will be faster also, I think. But
yeah, it can be done though. It's not not doable.
Just add 1, right? If it's 0 is on, we add 1, will become 1, right?
Yeah. You have to keep adding that. Yeah.
Yeah, in that case, if that because the max number can fit into like 64 bit, right? Like the long.
Yeah, the long.
So yeah, if we do the bit properly, that's gonna be. Would it be faster?
Maybe.
Yeah.
Because if it's like more than 64, if it is 128, then you'll have to take 2 of them, and then keep on increasing it if the number is more bigger. So it will be like almost an array. So I was thinking, why don't we take just a Boolean variable or a vector of Boolean variable and then do.
But with Boolean, that can be a lot, right? Boolean array size of n.
Yeah. The space complexity will be bigger in that case.
But is that true? Because right now we only have a nice example. We see that look like it, right? But if we keep going, and how it's not correct. If we use bit, it's not correct.
To check it out, I think.
But it seemed like look right. Yeah.
Let's try with bits if we can, but
yeah, no problem. So let's see if we can solve it a different way and then post it on the Slack, right?
Post it Slack. Yeah, definitely.
Okay.
Then let's wrap it up.
Yeah.
Okay. Thanks.
Thank you.
Thank you, everyone.
Thanks, everybody.